Today we'll be looking into introduction to differential equation. So when we talk about a differential equation is an equation which contains one or more derivative of a dependent variable with respect to some independent variable. When you have an equation that contains a derivative of of a dependent variable with some independent variable, a type of equation is called a differential equation. And under differential equation, we have ODE and PDE. What do we call ODE? ODE means ordinary differential equation, and also PDE, which is called partial differential equation, which is called PDE. So when we talk about ODE, ordinary differential equation is a differential equation in which the dependent variable depend on only one independent variable. That is only one independent variable. If you have a dependent variable, is a differential equation in which the dependent variable depend on only one independent variable. So example, if you have the y over dx is equal to 2x. Second example, y dash, that is y prime minus s is equal to 0. Number 3 example, the square y all over dx square is equal to 2x square minus 6. Then last example is the y over dx into 2 minus with x is equal to 0. So I want to explain what OD is called exactly. Remember that x is an independent variable. Then y is a what? Dependent variable. Y is dependent. X is an independent, y is dependent. If I have an equation as y is equal to 2x, so if I said x is equal to what? X is equal to 2. What am I going to have here? I'm going to have y is equal to 2 into 2, which is 4. Y is equal to 4. So it means that y depend on independent x, that is y depend on x. So that's why we have y as dependent variable and we have x as independent variable, because x does not depend on anything. Y only depend on x. So if you now have the differential, it means the derivative of that equation. Remember that if I have y, if I differentiate y, what am I going to have? I'm going to have the y over ds. So it means if you have a derivative of that dependent variable depend with an only one independent variable, we call that type of equation as what? Ordinary differential equation. You can see that if I have y, if I differentiate y, I'm going to have the y over ds. So the y over ds is a dependent variable. It depends on what? It depends on, if I have is equal to 2x, you can see that y as a dependent variable, derivative of y as a dependent variable depend on what? 2x, which is what? Independent variable. You can see it's only one independent variable, it is here. So that's why we call it ODE. And example is what? The y over ds is equal to 2x. Second example is y prime. If I have y, if I differentiate y, I will have the y over ds, or I can say y prime. So this dash means prime, that is first derivative. If I differentiate again, the square y all over dx square. This is I differentiate is a second derivative. I can have this as what? Y prime prime. So this sign means prime, that is first derivative. If I have double dash, second derivative. If I have triple dash, third derivative, that is I differentiate 3 times. So that is what we call ODE. That is what we generally call ODE, which is ordinary differential equation. So let us now go to partial differential equation. Partial differential equation. This is a differential equation in which the dependent variable depend on several independent variable. More than one. When the dependent variable depend on more than one independent variable, we call that type of differential equation as partial differential equation. So you can see for an example, we have partial square u all over partial s partial y. This sign is a dead sign and it's a small letter. This is a dead sign. We have this as a dead capital letter, or we have something like this as a dead. Small letter, capital letter, we call it delta. It's a Greek letter, delta. So, and we call this, we are using this in an equation, we call it a partial equation, and it's a partial because it's a partial. This example, partial square u all over partial x partial y plus 3 partial u all over partial y. This thing means first order. That is, we are differentiating this u with respect to y. We are differentiating this one, we differentiate this function of u. This u as a function of what? X and y. When we differentiate x, we differentiate that x again, and we differentiate that x again with respect to y. So that's what it means. You can see that here we are having more than what? More than one independent variable. Whenever we have more than one independent variable in an equation, we call it a partial differential equation. Another one is what? Del square u over del x, del y, del z. So this one is talking about x, it's talking about y, it's talking about z. It means u is having a function of x, y, z. U is a dependent variable. So the independent variable are x, y, z. You can say that x, y, z are the independent variable. They are more than one. So this is 3. So we can say it's a partial differential equation. And also again, number 3, del square u over del x plus del square u over del y square. It means u is also a function of what? X and y. That is, we are differentiating this. That is, u is a function of x and y, and u is a what? Dependent variable, and x and y is what? Independent variable, and it's more than one. When you have a dependent variable more than one, we call type of differential equation as partial differential equation. Another example, del square u over del x minus del x square minus 4 del u del y. You can see that u is this is u. U is a what? U is the function. That u is a function of what? X and y. So that's why we have del square u over del x. That is, u is depending on what? U is a what? Dependent variable. Why? X is what? X and y is an independent variable. U is depending on what? X and comma y. In some places, if I have 5x minus 2y, you can see this u as a function of x and y is affecting x, is affecting y. So that's why we call this a what? A good example of what? If I like differentiate this one, del u all over del x. What does that mean? It means I'm differentiating this u with respect to x. I mean, if I differentiate only with respect to x, I'm going to have 5 minus what? 0. So I'm going to have 5. If I differentiate again, I'm going to have del square u all over del x square with respect to x, which is 0. So you can see that what? Last example, u is a function of what? X and x and y is more than what? One independent variable. So let us now go to order and degree of differential equation.